Hello everyone, welcome back guys. Hope you all are doing well. This is Mohammad Badruddin back again with another module named as Web Cache Deception Vulnerability module from Portswigger. Before going to solve the lab of this module, I will first describe and brief about the Web Cache Deception vulnerabilities. But before jumping to this module, I will highly recommend you guys to first attempt or first go through the web cache poisoning vulnerability module, which I already recorded, and all the labs are there in a playlist named as web cache poisoning on my YouTube channel. That is very important because I already explained most of the terminology about the web servers containing the cache server. So how that cache and origin servers mechanism works, what are the terms, like what kind of headers you will see in the responses with different frameworks, okay, what is cache key, and all these terms I already explained there. So if you go through that vulnerability module named as web cache poisoning, this module is going to be a little easy for you because you already know the terminology and how the cache works, how you identify and analyze the requests and responses that have cache mechanisms inbuilt. Okay, so let's go, and I'm going to just describe a few things about the web cache deception, and I will highly recommend you guys to just go through this. This is very important to know about what you are going to do. So our purpose is not to just solve the lab. Our purpose is to understand the concepts and methodologies about behind every vulnerability and how you can exploit it. So you must know the methodology, you must know the concepts so that you will have a correct mindset or thought process to exploit the specific kind of vulnerability, right? So that's been said. So what is web cache deception vulnerability? Basically, this vulnerability occurs when an attacker manipulates URL to trick a web server into caching sensitive or private information that should not be stored in the cache. Fine. And the attacker actually craft URL in a way that the web server misunderstand the request resources and leading to the storage of unauthorized content in the cache. And I will explain this within this picture. So this picture very correctly define the vulnerability. So this attacker is crafting an arbitrary URL and send this URL to the victim. Then this victim is trying to access this URL sent by the attacker, and once that URL go to the cache, now there is one most important thing in this vulnerability, and that is disagreement and conflict, or maybe misconfiguration or misimplementation between the server and the cache, because there are some rules in the cache. So if you are going to configure the cache for a specific origin server or web server, so you must have to define or configure the cache rules, and according to that cache rules, the cache server will only cache the content according to that rules, okay, or followed by that rules. So if the implementation is not correctly done or there is misconfiguration, this vulnerability occurs. So as you can see here, once this user access the URL sent by the attacker, that goes to the cache, and cache try to interpret this URL, okay, and if it already has the resource in the cache, it will serve that response to the user. But because this is an arbitrary, so most probably the cache does not contain this content already for this resource, so it will send this to the origin server, and origin server interprets the same request in some other way. And according to that, the server will send the response in the cache, and it will be stored in the cache, and that response contains some sensitive or critical information. Now, because the information or the critical information is already now within the cache, the attacker will generate this arbitrary URL and send to the victim, and victim already access that, and the sensitive information is already in the cache. So the attacker will use the same URL and it will fetch the information stored in the cache. Okay, so this is the terminology of this attack, which is known as web cache deception. Now let's see. Web cache deception is a vulnerability that enables an attacker to trick a web cache into storing sensitive dynamic content, and it is caused by discrepancies between how the cache server and origin server handle request. So discrepancies means disagreements between cache server and the origin server. This cache server and the origin server, and the disagreement between cache server and origin server of what? Of how they both handle the request. Now this is, suppose this is the arbitrary URL which is interpreted by the cache server in some different way, but in the origin server it interpret it in a different way or in a different manner. I will go into this particular or specific thing in a minute because it's mentioned here already. So I hope you understand what is web cache deception vulnerability. Now, in a web cache deception attack, an attacker persuades a victim to visit a malicious URL. So you can see here, this is the attacker which sends an arbitrary URL to the victim, and victim is going to access this URL sent by the attacker, including victim's browser, to make an ambiguous request for sensitive content. The cache misinterprets this as a request for a static resource and stores the response. Fine. Now the cache is going to interpret this URL in some different way. So it's not correctly interpret this, and because the cache does not contain that information within it, and it is going to pass that to the origin server, and origin server will send the response to the cache that contains the sensitive information. And now the sensitive information is in the cache, so this attacker will access the same URL to access that content, because still the cache will interpret this URL as it interprets before when the victim sent this URL, send the request to this URL. Fine. So the attacker can then request the same URL to access the cached response, gaining unauthorized access to private information. Fine. Now there are some important things, but before this important thing, I want to show you something which is this path mapping discrepancies, means path mapping disagreement, what we were seeing here. Okay, the cache misinterpret this. Now this is happening because how the origin server interprets the resources and the cache server interprets the resources, and that you will see here. So there are actually two common styles. The first one is traditional URL mapping, and the second one is RESTful URL mapping. Okay, so in traditional URL mapping, you are going to point out the specific resources with complete path. Okay, now suppose that you put a web server directory, web application directory within var www in HTML, or like let's say cd, or let's say ls var www html. Okay, now suppose that I have this index.html within this path, right? So the same thing, so it's specifying the specific resource or specific file with the exact file path. Okay, so here this http://example.com, this is the server, so points to the server. Then path in the file name, this is the path of the file name where the resource reside, and resource.html is the exact file or exact resource which you are trying to access. But in the RESTful APIs or in the RESTful URL mapping, so you do not directly match the physical file structure because there is an abstraction. How? It is going to specify path like this. This is the server name, then path, then resource, then parameter 1 and parameter 2. So this is the server, path and resource is the endpoint representing a resource. So this is what the thing here, that after the domain name you have the path, exact path of the resource in the traditional URL, but in RESTful you have the endpoint representing a resource, just endpoint, not the file name. And then we have parameters. Parameter 1 and parameter 2 are the path parameters used by the server to process the request. Now, how this disagreement occur? You can see that within this example. Suppose that I'm going to try to access this resource, and this is, you can see, this is a traditional URL. Okay, to point out a specific resource, which is this, with the exact file name. So this is the domain name, this is the path where this wcd.css file exists. So an origin server using RESTful style URL mapping may interpret this request, this URL, as, because the origin server is interpreting or mapping URL with RESTful style, so it is going to consider user 123 profile as the endpoint and return the profile information for the user 123, and this will not count wcd.css because this is not traditional. The origin server is not following the traditional URL mapping. So here what happening, you can see, if I consider that this server is interpreting or mapping the URL as RESTful mapping, URL mapping, so it is not going to consider this a.js. So it will only interpret this with this endpoint / profile is the last one. But if the cache server is interpreting this URL as a traditional URL, so it is going to try to access this a.js from the origin server, but the origin server is following another way for mapping of the URL. It will not consider this, and it can be vice versa. Fine. So this is actually the disagreement between the cache and the web server. So where we are here. Now let's see. Now if the cache server that uses the traditional URL mapping may see the same URL in a different way. How? You can see it will say, okay, this is the domain name and this is the path for the resource, which is wcd.css. Fine. So this file name wcd.css located in the profile within the directory user /123. So it interprets the URL path as this one. Now, if the cache is configured to store responses for request where the path ends in .css, it would cache and serve the profile information as if it were a CSS file. Fine. So this is the disagreement. Okay. How origin server, and the cache is going to map the URL. Fine. This was the first thing. Now the second thing, which is very important for uh, web cache deception, is that you should not interpret web cache poisoning and web cache deception vulnerability as same. No, it is not same. It is very much different from each other. In web cache poisoning, the attacker manipulates cache key to inject malicious content into the cache response, okay, which is then served to the other user. So any user will come to the cache in the specific time. The response or the injected malicious response is going to be served to that victim, to that user. But in web cache deception, the cache rules to trick the cache into storing sensitive information or private content which the attacker can then access. So the purpose of the cache is same. The purpose of the cache is it will take some response from the origin server, storing into its storage, and then anyone come within the specific time, the user will get the same response which is already stored. If the user is trying to access the same resource which is already stored in the response, so the cache will serve that response to any user coming to that cache server. Fine. But in the deception, attacker assume that the victim user already access that URL, and whatever the sensitive information now comes into the cache or stored in the cache, the attacker will access the same arbitrary URL to fetch that information from the cache. So cache mechanism is same. So in the cache poisoning, the attacker inject malicious content, and that content is served to all the users. And in deception, attacker manipulate or generate a arbitrary URL, send it to the victim. Victim call or make request on that URL, and because of the disagreement between the cache and the origin server, the server will send the sensitive information. It is stored in the cache, and then attacker access the same arbitrary URL to fetch that information. So this is all web caches that I already explained here in a very brief, and I already explained it in the web cache poisoning vulnerability module. So please watch that module so you understand this web cache concept. Cache keys that already I explained there in the web cache poisoning module. If you go through that module, you will know everything about the cache keys. Okay, and if you want to read, of course, you can read it here to understand. Now I talk about cache rules when I was describing web cache deception or the cache. So what are the cache rules? That is very important, which I did not covered in the web cache poisoning, so I should cover it here. So you might have heard about the content delivery networks or content distribution networks, CDNs. So once the CDN is configured for any specific site or application, so what happened, for the cache you need to define some rules. Same like once you put the firewall, you define some policies and rules in the firewall to block or to allow some specific ports or some kind of content or some kind of URLs, whatever. Same like once you put the cache mechanisms, okay, or cache servers, you need to configure that cache application and you need to define some rules. There are more advanced rules, but some basic rules are here, like static file extension rules, static directory rules, and file name rules. So you can see the first one here is static file extension rule, where these rules match the file extension of the requested resource, for example .css, .js. The second one is static directory rules. So these rules match all URL paths that start with a specific prefix, okay, or specific directories that contain only static resources, for example /static or /asset. File name rules again, so that actually point out the specific files like robots.txt and favicon.ico. So these are actually the universal files. You might have encountered these files a lot of times. Okay, so cache may also implement custom rules based on other criteria such as URL parameters or dynamic analysis. So as I mentioned before, that these are only the basic rules, but in real world scenario you can make your custom rules according to whatever you want. Now constructing a web cache deception attack. The first one says that identify the target endpoint that returns a dynamic response containing sensitive information. So this is very important, because without this, how you will know that which endpoint you need to target, because not all the endpoints will have sensitive information and dynamic responses. So you can review responses in the burp, as some sensitive information may not be visible on the rendered pages, of course, because we can see we have more and more visibility on the burp suite where we intercept the request. So focus on endpoints that support the get method, head method, and the option HTTP methods, as requests that alter the origin server's state are generally not cached. So the second point is saying identify a discrepancy or disagreement, okay, in how the cache and origin server parse the URL path or map the URL path. So this could be a discrepancy in how they map URLs to resources. This is the first thing. Process delimiter characters, okay, and normalize the path. Process delimiter character, this is basically more important because different frameworks behave differently on different meta characters or delimiter characters. Fine, so we will see that all those things while we will solve the lab. The third point says craft a malicious URL that uses the discrepancy to trick the cache into storing a dynamic response. So when the victim accesses the URL, their response is stored in the cache, and using burp suite you can then send a request to the same arbitrary URL which attacker means you or us, to fetch the cached response containing the victim's data. So avoid doing this directly in the browser, because some application redirect user without a session or invalidate the local data, which could hide a vulnerability. So if you maybe try to directly access that arbitrary endpoint on the browser, so you may be redirected to the login page, or maybe on the other page, or you may get some different kind of errors or warning or status responses. So it's better to work on some kind of reverse proxy for this. Okay, there is a tool named as Cache Buster within the burp suite that you can use to automatically test the discrepancies and crafting a web cache deception exploit. We will also use that if we needed. So detecting cache responses, that I already explained a lot in the web cache poisoning vulnerability module. Don't forget to just go through that because you will get too much information there. Here you can see if there is a mechanism between you and the origin server. If there is a mechanism of cache headers, you will find X cache, and the value of the X cache is different for different kind of behavior or responses. Like if you get the X cache response header in the response with the value hit, that means the response you get as a user you get that response from the cache. And if you get X cache value is equal to miss, that means the response you get as a user, that response is coming to you from the origin server. Fine. Because that response was not stored in the uh, cache, so that's why you get that response from the origin server. Because the cache servers contains or store the information or store the responses for a specific amount of time. So if that time has already passed and no other user try to access the same resource, that means uh, again you once you make the request, that request is going to the origin server, because cache did not have that response already stored. Now if you get the X cache value as dynamic, that means the origin server dynamically generate the content, and generally this means the response is not suitable for the caching. If there is some kind of feature or some kind of information that every time server generates dynamically, that information is not static, so at that instant you will know with this response header value with dynamic that the origin server generate that content automatically. If you get the value X cache is equal to refresh, that means the cached content was outdated and needed to be refreshed or revalidated. Also, if the cache mechanism is there, you may encounter this response header also, which is cache control, and this cache control will give you some other values like maximum age, which is if it is higher than 0, that means you are already getting the response from the cache. So cache control header may include a directive that indicates caching, like public with a maximum age higher than 0. Okay, so note that this only suggests that the resource is cacheable. It is not always indicative of caching, as the cache may sometimes override this header. Fine. Now if you notice a big difference in response time for the same request, this may also indicate that the faster response is served from the cache. Fine, so this is all about that. And here exploiting path mapping discrepancies, this is gonna be the first lab, and we will see this thing in more detail in the first lab, which we will cover or which we will solve in the next video. So for this video I think it's enough, and in the next video we will solve the lab. So if you like the content, please like, subscribe and share, and I'm gonna see you in the next video. Bye.